The question states why this complex doesn't exist. So why this complex does not exist, we have to understand by its oxidation numbers. Let's calculate the oxidation numbers of platinum in this complex. So this is also a type in which both the cation as well as the anion are complexes. So again, first of all, we'll assume the charges on the cationic part to be +1, the charges on the anionic part to be -1. So now let's start try to find the oxidation state of platinum in the cationic complex. So for the cationic complex, X plus 2 into NH3 plus 2 into Cl will be equal to +1. That gives you X plus 0 minus 2 is equal to +1, which gives you X is equal to +3. So that is wrong. If your oxidation state of any atom in the cationic complex comes wrong, do not try to solve it for the anionic complex, because obviously that is wrong. So just let's move on to the next numbers. So this is wrong, that is +1 and -1 are not the charges on the cationic and anionic complex. Let's look at +2. And -2. So let's try to solve for cationic part first. So X plus 2 into 0, that is the 0 is for the neutral charge of NH3, plus 2 into -1, that is for the negative charge of chlorine, is equal to +2. So X minus 2 is equal to +2. This shows that X is equal to +4. So yes, platinum does show a +4 charge. So the cationic part is okay. Let's do for the anionic. Once you see that the charge or the oxidation state of the cationic part is okay, then you move to the anionic. But if the cationic part comes wrong, then you do not have to go to the anionic one. So for the anionic, we have X plus 2 into 0, same thing, plus 2 into -1 is equal to -2. X minus 2 is equal to -2. This makes X is equal to 0, which is not true. Platinum does not show an oxidation state of 0. So this is also wrong. In all the other cases that you will see, if you do +3 and -3 and +4 and -4, which is the highest that you can go up to, in all of them your platinum will not show the correct oxidation states. So if it does not show the correct oxidation state, means this compound does not exist. This compound does not exist because oxidation states of platinum are not correct. The next question is why only CuCl4 negative exists but CuI4 negative does not. So this lies in a little more complex, that is, you have to know what is the nature of the ligands here. In this case, both in CuCl4 negative as well as CuI4 negative, the copper exists as Cu2 positive. You can try to find the oxidation state. The oxidation states of copper in both of them is copper 2 positive. But the catch with CuI4 negative is, in CuI4 negative, iodine exists as iodide, right? And iodide is a very good reducing agent. So when Cu2 positive is present with iodide, the iodide reduces the Cu2 positive to give Cu positive, and itself it gets oxidized to iodine. That is why this complex does not exist, because if it exists it will not, because it will reduce the Cu2 positive to Cu positive, whereas chlorine is not that good of a reducing agent. So it does not do that. It does not reduce the Cu2 positive to Cu positive. So this exists happily. whereas this does not exist. So this question is a culmination of everything that we have studied till now. We have to determine the coordination number, we have to determine the oxidation number, and we have to determine the number of the d electrons in the metal ion of the complex respectively. So in your A, B, C and D, the number of d electrons are 6, 6, 6 and 6. So you need not calculate the number of d electrons, you just need to focus on the coordination number and the oxidation state. So the complex is COCl2 En2 Cl. If this complex is COCl2 En2 Cl, this means that the coordination number of cobalt here will be 6. Why it is 6? Because 2 of the coordination numbers are coming from chlorine. Chlorine is a monodentate ligand and there are 2 chlorines present. So 2 coordination number from chlorine, and En is a didentate or a bidentate ligand and there are 2 of it present. So 2 into 2, 4. So 4 of the coordinations are satisfied by En and 2 of the coordination is satisfied by chlorine. So that gives us a total of 6. So the coordination number is 6. So it can either be B or it can be C. Now we have to find the oxidation number. So again we will find the oxidation number. X minus 2, 2 because there is negative charge of chlorine, minus 1 and there are 2 chlorines present, plus 0 because En is a neutral ligand, and minus 1 because there is chlorine present outside also and there is no charge on the entire complex. I'll equate it to 0. So that gives us X is equal to plus 3. So this is our correct option. Now even though you do not have to calculate d electrons in this question because the number of d electrons is 6 in all of the options, that means the number of d electrons is 6, but still we will try to calculate and see if it is actually 6 or not. So the oxidation number of the cobalt is plus 3, that means cobalt is present as CO3 positive. This means cobalt has lost 3 electrons. Cobalt has a configuration of 3d7 4s2. If it loses 3 electrons, it is going to be 3d6, right? It is going to lose 2 electrons from S and 1 electron from D, which makes it 3d6 4s0. So this is also confirmed that the number of d electrons in the metal ion are 6.